I am Avishala Madhuri. I am from EC department. My team members are P. Balaji and Bandar Manoj. Now I will discuss about the spatio-temporal coding for wireless communications. This is the abstract of the spatio-temporal coding for wireless communications. A compact model is derived for the multiple input and multiple output MIMO. This pursues spatially selective wireless communication channel. The multivariate information capacity behavior is then analyzed for various input and of output antennas configurations. Now introduction. The study of reliable communications in linear channels was initiated by the work of Schoner in 1948, and the information capacity of the certain multiple input and multiple output channels with memory was derived by Brandenburg and Wiener. Recent work by Cheng and Verdu derives the capacity region for more general multi-access MIMO channels. Our objective is to find spatio-temporal coding structures that asymptotically achieve theoretically channel capacity. First, a compact model is developed for such channels. We then find the theoretical information's capacity and limits of the MIMO channels. MIMO means Brandenburg Wiener derived the capacity of discrete time continuous frequency. Invertible M into M channel, we are interested in more general MR into MT channels. So we provide the generalized capacity results in the theorem 1. So this is the diagram of the introduction, path, amplitude and delay. So here left side is the transmitting array and then right side is the receiving array. So this is the channel path.
Myself Balaji from EC department. MIMO channel model. Wireless communication channels are often characterized by severe multipath. The transmitted signal propagates along L multiple paths created by reflection and scattering from physical objects in the terrain as illustrated in the figure 1. We derive a far field signal model for linearly modulated digital communication for a system with MT transmitting antennas and ME receiving antennas. This is a diagrammatic representation of MIMO model in where a radio port and a remote unit will be connected using paths of dominant reflector like natural calamities and buildings or reflectors. Spatio-temporal channel capacity. The capacity value for each of these channel configurations are denoted as CJ, CM, I, C1, MT and CM respectively. The singular valued decomposition of H is equal to UHA HU with the jth singular value denoted 4. This assumption eliminates the mathematical inconvenience of dealing with the ratio 9 that would otherwise appear in Colaris 1 and 2 when MT2 minimum L, MR. The result can easily be extended to the correlated spatio-temporal interface pulse noise case with a pre-whitening receiver filter matrix approach.
My name is Bandar Manoj. Experimental examples. In this section, the results of wireless DMMT simulation experiments are reported. The first experiment compares the capacity of an example multipath MIMO channel with the capacity of the underlying SIMO and SASO channel blocks. The second experiment illustrates the decrease in MIMO channel capacity that occurs if the number of multipath components is less than the number of input and output antenna elements. This is the graph of mean SNR per symbol. Conclusion. A model was developed wherein the difficult two-dimensional problem of communicating with dispersive MIMO channels was collapsed into a one-dimensional vector equation. The information capacity was then analyzed. Multipath can significantly improve the capacity of MIMO channels. If L greater than minimum, then at high SNR values, the capacity slope increases linearly with the minimum of the number of antennas. References. These are the team members. Thank you.